Good evening, good evening. Om Shri Mahaganadhipataye. Good evening to all. I think you are ready with your books and all those. Okay. As I told you that today I am going to teach you, I am going to make you learn all the problems of trigonometric identities from R.S. Agarwal today and tomorrow. In total there are 31 or 32 problems are there. We will see each and every one because I want you to learn all the problems from identities because identity is a very important topic and the last topic in the introduction to trigonometry chapter. Then we need to go for applications of trigonometry. Okay children? Okay, if you are ready, we will start. So everyone start typing, we are ready. We are ready. Start doing it. Start. Type it, we are ready. Can you hear me? Children, can you hear me? Hello? Can you hear me? Children, can you hear me? Okay, ready, good. I thought you are not able to hear me clearly. So can you hear me now? Yes, thank you. Thank you. I am getting the answers now. Okay, good Nana, good. So here, before going to the topic, just I want to recall the identities. The first one is sin square A plus cos square A is 1. Then sin square A is 1 minus cos square A is 1 minus sin square A. The second identity is secant square A minus tan square A is equal to 1. Secant square A equals to 1 plus tan square A and tan square A is equal to secant square A minus 1. The third identity, cosecant square A minus cot square A is equal to 1. Cosecant square A equal to 1 plus cot square A and cot square A equal to cosecant square A minus 1. And one more important point I told you children, if you find like this anywhere, be ready to write this one as 1 plus sin A into 1 minus sin A, because we can write or we can express it as 1 square minus sin square A square minus B square, A plus B into A minus B. In the same way, wherever you get like this cosecant square A minus 1, you need to write it as cosecant A plus 1 into cosecant A minus 1, because it is also in the form of A square minus B square. So children, this A plus B into A minus B identity from algebra, which is also playing an important role in problem solving in trigonometry. Okay na? So here I am going to start the problem number 1 from R.S. Agarwal. That is sin power 4a minus cos power 4a equals to 1 minus 2 cos squared a. This is the first problem in trigonometric identities in R.S. Agarwal. So how to do this? As it is, I told you now, write this one as sin square A whole square and this one as cos square A whole square. Now the problem is converted into A square minus B square form. So A plus B into A minus B. A plus B into A minus B. And we know this is 1. Very good. And this one Sin square A minus cos square A. But children, if you see the answer, and what we got now, any guesses what to do now? Any guesses from you? Any guesses, children, from you? What we have to do? The answer is 1 minus 2 cos square A. But we got sin square A minus cos square A. There is only one step remaining. What to do now? Can any guesses from your side? Anyone? Anyone? Sanvi or Teja means Buddepalli, Manoj? Anyone from the class? Any guesses? What to do now? Okay. Then I will tell you. What I will see here. Sin square A I will write it as 1 minus cos square A and minus cos square A. So 1 minus cos square A minus cos square A minus 2 cos square A. So the answer is 1 minus 2 cos square A. We got the answer. Understand, children? If you understand it, kindly type yes. Yes. Can you hear me, children? Okay, good. Next, I am going to the second problem now. Second problem. The second problem is sin power 4a plus cos power 4a by 1 minus 2 sin square a cos square a. We need to prove that the result is 1. Okay, children? Any guesses? Any guess? See, children, one thing I am going to tell you is algebra is going to play an important role in problem solving in trigonometric identities. So if you see, we have an algebraic identity that a square plus b square is, we can write it as a plus b whole square minus 2ab. A square plus b square we can write it as a plus b whole square minus 2ab. This identity, this one you have to remember in problem solving, which is very, very important. Okay, right. So why I wrote this one? You can observe if you see the numerator. See the numerator. I can write it as sin square a whole square plus cos square a whole square by, just I am not writing this one, just I will write denominator. Denominator I am not going to touch. So just instead of writing all these waste of time, I am writing simply denominator. Okay. Now see the numerator. See, numerator is in the form of a square plus b square. So I can write it as a plus b whole square minus 2ab. Is that right, children? Okay. A plus b whole square. A is sin square a, b is cos square a. So a plus b whole square minus 2ab, 2 sin square a cos square a by denominator. As it is denominator, no need to touch it. Okay, children. Now, if you see the term in the brackets, which is sin square a plus cos square a, sin square a plus cos square a, I think it is 1. Is that right? Sin square a plus cos square a is 1. Is that right, children? Okay. Now, 1 square minus 2 sin square a cos square a by denominator as it is. Okay. Now, 1 square is 1 only. Okay. So what we have now, you see, 1 minus 2 sin square a cos square a, and I wrote it as denominator. What is denominator? What is denominator, children? Which is also 1 minus 2 sin square A cos square A. So cancel and we got the result 1. Understand, children? We got the result 1. Okay na? Now I am moving on to problem number 3. I am moving on to problem number 3 now, children. So what is problem number 3? Yes, 1 plus cot square theta by 1 plus cosecant theta is equal to cosecant theta. We need to prove that this whole thing is equal to cosecant theta. That is what we have to prove. Okay. So, any guesses from your side? Where to start? How to start? Any guesses, children, from your side? Can anyone say something here? How to start this problem? Children, 1 plus cot square. Sir, we can note down. Yes, you can note down, Najista. Not like that. Any guesses? We write cot as sine, cos by sine. Okay. Any other guesses? Any other guesses? See, children, we need to get the result as cosecant theta. Children, you need to participate. Cross multiplication, okay? Any other guess? Yes, Akanksha, good. So, Akanksha is telling us that cot square theta, we need to write it as cot square theta as cosecant square A minus 1. Cosecant square theta minus 1 plus cosecant theta. Cot square theta, we can write it as cosecant square theta minus 1. Class lone cheppanu. Just look at the given problem and answer. Try to move to answer. Means we need to move in that direction to that answer what we are having. Answer is cosecant theta. So here denominator we have cosecant theta. And numerator also we need to convert into cosecant square theta. So now, in the beginning of the class I told you, we need to habituate that cosecant square theta minus 1 can be written as cosecant theta plus 1 into cosecant theta minus 1 by 1 plus cosecant theta. Starting lone cheppanu. We need to habituate that habit that whenever we see cosecant square theta minus 1, if it is needed, we need to write a plus b, a minus b form. I told you. Now you see. This cosecant theta plus 1 and 1 plus cosecant theta get cancelled. Now what is remaining? 1 plus cosecant theta minus 1. And 1 and minus 1 get cancelled. The result is cosecant theta. The result is cosecant theta. Understand, children? Okay, good. Next one. Next one we'll see. Yeah, next one. Secant A minus cos A into cot A plus tan A, and the answer is secant A tan A. The answer is secant A tan A. Okay, see the problem. See the problem and answer also. Okay, children. Answer is in terms of secant A tan A. So that means we need to convert the other ratios into secant A tan A's. Okay, children. So for that what to do? Cos A, write it as 1 by secant A, because the answer is in terms of secant A tan A. And here cot A, you write it as 1 by tan A plus tan A. Understand children? మీకు చెప్పాను అందుకని ఆన్సర్ ని చూసి ప్రాబ్లం సాల్వ్ చేయాలి. Trigonometric identities లో ఆన్సర్ చూడు. See the answer in the form of secant A tan A. So we need to convert this cos A and this cot A. So cos A we know reciprocal of secant A and cot A is reciprocal of tan A. So now take LCM. Secant square A minus 1 by secant A into 1 plus tan square A by tan A. If we take LCM here by 1, if we take LCM, what we will get here? Here secant square A minus 1 by secant A, and here 1 plus tan square A by tan A. Now secant square A minus 1 is nothing but tan A. Tan A by secant A. Secant square A minus 1 is nothing but tan A. Identities. And 1 plus tan square A. Children, 1 plus tan square A. Secant square A by tan A. I think answer is done. Answer వచ్చేసింది అనుకుంటా. ఏం చేయాలి ఇప్పుడు? What to do? We got the answer, children. What to do now? What is the last step? Anyone? What is the last step? Neha Devi, tan square A. Yes. Sorry. Good, Neha. Tan square A. Good. Now what next? Is the answer is done? Is the answer is done? Cancelling. Good. Now cancelling. Good. Just here. Out of tan square A. If one tan square A is one tan A is get cancelled, remaining is one more tan A. And here also secant A. So the answer is tan A into secant A, which is our answer. See, secant A tan A, and we got the same. Understand, children? Yeah, don't waste the time in writing. After completion of the problem, try to take screenshots if you want. Okay. So can I move to the next one? Can I move on to the next one? Okay, good. Good. Next question. Question number 5. 1 plus sin theta by 1 minus sin theta is equal to secant theta plus tan theta whole square. 1 plus sin theta by 1 minus sin theta equals to secant theta plus tan theta whole square. Children, very important model. Please put 2 to 3 stars on this problem like this. Very important model. Put stars like this on this model. So children, this problem we can start by taking LHS and proving RHS, or by taking RHS and proving LHS. We can do on both sides. But in this particular problem, it is easy if we consider this one as a given problem and this is the answer. That will be easy. Understand, children? Or we can do this one also. Which one we'll do? We'll consider LHS and show answer RHS, or RHS will consider our answer LHS. Which one we'll do? Which one we will do, children? We'll consider LHS, huh? Okay, good. We'll consider LHS, right? And we'll show the answer as RHS. Remember, answer is secant theta plus tan theta whole square, and I'm rubbing that one. Okay. Now, see, I will multiply the numerator and denominator both with 1 plus sin theta. మీరు అంటుంటారు కదా rationalize denominator. Actually rationalization కాదు, because we don't know What is 1 plus sin theta and what is 1 minus sin theta? Rationalization ankodu. You can't say like that. Just I am multiplying the numerator and denominator with 1 plus sin theta. Okay na? Now what happens? A plus b into a plus b, a plus b whole square by a minus b into a plus b, a square minus b square. A square minus b square. Now children, this is as it is, numerator as it is, and denominator 1 square is 1. Now can anyone say what is 1 minus sin square theta? What is 1 minus sin square theta? Any guesses? What is 1 minus sin square theta? You are not liking this live class? Only 9 likes I got? Okay, no problem. I don't want likes also. Yes. 1 minus cos, right. Who is this MESJ? Good. So 1 minus sin square theta is cos square theta. If I say, children, if I say that the problem is done, how many will accept it? If I say the problem is done, only one more step left. If I say like that, who will accept it? Not accepting? Will say yes sir, the problem is done. Who will say like that? Problem is done. Kavindra. If I say the problem is done, okay, I'll tell you. How I tell you? So this, we have an identity. We have a exponential identity, a power m by b power m. We can write it as a by b whole power m. Is that right, children? A power m by b power m. We can write it as a by b whole power m. So like that. 1 plus sin theta whole square by cos square theta. We can write it as 1 plus sin theta by cos theta whole square. By using this formula, 1 plus sin theta whole square by cos square theta, we can write it as 1 plus sin theta by cos theta whole square. And this one, what I do is, I write this one as 1 by cos theta plus sin theta by cos theta whole square. And we know 1 by cos theta is secant theta and sin theta by cos theta as tan theta whole square. So the answer is secant theta plus tan theta whole square. So the problem is done. Understand, children? The problem is done. Okay. Good. What TES, Drupad? What is TES? Yeah. Yes. Okay. Now, we'll go ahead with another problem. Now. Problem number 6. Sin A into 1 plus tan A plus cos A into 1 plus cot A, and the result is secant A plus cosecant A. The result is secant A plus cosecant A. So how to do this problem? How to solve this one? Any guesses? Just multiply. First multiply. Sin A into 1. Sin A plus sin A into tan A. Sin square A by cos A plus cos A into 1 cos A, cos square A by sin A. Okay. Now what to do? We need to take LCM. What is LCM? Cos A sin A. So here what we will get? Sin square A cos A plus, and here sin cube A plus sin A cos square A plus cos cube A. Okay na? Now what we have to do? So from first to 2 we can take sin square A common. First to 2. If I take sin square A common, remaining is cos A plus sin A. And here also cos square A common. Cos square A common. From the last to 2. From the last to 2 cos square A common. What is remaining? Sin A plus cos A by denominator. Okay. Now what we can do? We can do cos A plus sin A common. Cos A plus sin A common. What is remaining? Sin square A plus cos square A by denominator. Okay, children. Now we know what is sin square A plus cos square A. We know it is. It is nothing but 1. Sin square A plus cos square A is nothing but 1. So I'll take out this one. I'll take out this one. Now, what we are left with? Cos A plus sin A by denominator cos A sin A. Now what we have to do? We need to separate this. Cos A by this plus sin A by this. We need to separate. Cos A by this plus sin A by this. Cos A by cos A sin A plus sin A by cos A sin A. I think we done with the problem. Say yes or no, children. Try to write the last step. Try to write the last step. Are we done with the problem or not? Children, are we done with the problem or not? We done with the problem. How? See here. Cos A get cancelled and sin A get cancelled here. So we are left with 1 by sin A plus 1 by cos A. 1 by sin A is nothing but cosecant A and 1 by cos A is nothing but secant A. So the answer is cosecant A plus secant A. Okay, children. See here. What we have to do first? We need to multiply monomial into binomial. Monomial into binomial. Okay na? Sin A into 1, sin A into tan A. We know tan A is sin A by cos A. Tan A is sin A by cos A. So, sin A into tan A we can write it as sin square A by cos A. We know tan A is sin A by cos A. Tan A is sin A by cos A. So sin A into sin A by cos A. Sin A into sin A by cos A. Sin square A by cos A. Plus cos A into 1 cos A and cos A into cot A. And cot A we know cos A by sin A. So cos A into cos A by sin A, cos square A by sin A. Then taking LCM, and taking common factors from these two, we need to take sin square A common, and from these two we need to cos square A common. We need to take cos square A common, and the problem. So can I move to the next one? Can I move to the next one, children? Yeah, you need to give answers. Can I move to the next one? Yes. Only one is giving. Only one is giving. The remaining are sleeping. Moving on to the next problem. At least we need to finish. Problem number 7. Secant power 4a minus tan power 4a is equal to 1 plus 2 tan square a. This is the answer. Secant power 4a plus minus tan power 4a. Yes. How to do this? Problem is like this. An answer we need to prove 1 plus 2 tan square a. Children, I told you in the beginning of the class, a square minus b square equal to a plus b into a minus b. That one will work out here many times, that identity. So I am going to write this secant power 4a as secant square a whole square and tan square a whole square. Secant power 4a is secant square a whole square and tan power 4a is the tan square a whole square. So secant square a plus tan square a plus b and a minus b. Secant square a minus tan square a. Okay na? A plus b, a minus b. And we know the result for this. We know the result for that one. Can anyone type that the result? Can anyone type the result? What is secant square a minus tan square a? 1. Okay, Hamsini, good. Good one. Good. And can I say with this the problem is done? If I put 1 over there, can I say the problem is done? Yes, problem is done. See that one. How I am writing the secant square a as 1 plus tan square a plus tan square a into this is 1. This is 1. So 1 plus tan square a plus tan square a 2 tan square a. Tan square a plus tan square a is 2 tan square a. So the problem is done. We need to prove 1 plus 2 tan square a only, na? Done. Understand, children? Very good. Next one. I am going ahead with the 8th problem. 8th problem. Sin theta by cot theta plus cosecant theta minus sin theta by cot theta minus cosecant theta. We need to prove the result is what? 2. Yes. We need to prove the result is 2. How to do this? ఇది చూడటానికి చాలా పెద్ద సమ్లా కనబడుతుంది కానీ సింపుల్ గా అయితే will feel like it. Can I do? Children? Can I start? Okay. Just see what I am doing. I take this sin theta common initially. What I left with 1 by cot theta plus cosecant theta minus 1 by cot theta minus cosecant theta. Now sin theta into, I will take LCM now. What is LCM? Cot theta plus cosecant theta into cot theta minus cosecant theta. That is LCM. So what I will get here on the top? Here I will get cot theta minus cosecant theta minus, and here cot theta plus cosecant theta. Now sin theta, open the brackets, cot theta minus cosecant theta minus cot theta minus cosecant theta by, see children, denominator is in the form of a plus b into a minus b. Denominator is in the form of a plus b into a minus b. So I can write it as a square minus b square. A square minus b square. Now, if you see this plus cot theta minus cot theta get cancelled. Plus cot theta minus cot theta get cancelled. And we will be remaining with this sin theta into minus 2 cosecant theta by, any guesses for the denominator? Any guesses for the denominator? Children, any guesses from your side? Akanksha says 1, Hamsini 1, Neha Devi 1, only 3. Aditya is also 1, Abdeli 1, everyone is 1. Okay, kindly see that one. Cot square theta minus cosecant square theta. It is not 1. Who says this? Sanvi. It is not 1. It is not 1, children. It is, we have an identity that cosecant square theta minus cot square theta, which is 1. But here it is reverse. Cosecant square theta minus cot square theta is 1. But here cot square theta minus cosecant square theta. What will be the answer? It is minus 1. This is 1. This is 1. See this? It's reverse. We need to put it as minus 1. So this minus minus get cancelled. dr remains with sin theta into 2 cosecant theta. And these two are reciprocal to each other, na? Sin theta, cosecant theta, both are reciprocal to each other. So the result is 2. We got the answer. The result is 2. Understand, children? Very nice. Very nice. Yes. Very nice. Next one. I am going ahead with the 9th problem. So what is 9th problem? Cosecant A minus sin A by cosecant A plus sin A, and we need to prove it as secant square A minus tan square A by secant square A plus tan square A. Cosecant A minus sin A by cosecant A plus sin A equal to secant square A minus tan square A by secant square A plus tan square A. How to do this? Any guesses? Any guesses, children? Any guesses from your side? Cosecant A minus sin A by cosecant A minus 1. What is minus 1? What is minus 1? So, what I will do is, I will consider LHS. I will write 1 by cosecant A as 1 by sin A. 1 by sin A minus sin A by 1 by sin A plus sin A. If I take LCM, what I will get here? 1 minus sin square A by sin A by 1 plus sin square A by sin A. Sin A get cancelled. We are remains with 1 minus sin square A by 1 plus sin square A. Okay na? So, here 1 minus sin square A is 1 minus sin square A is cos square A by 1 plus sin square A. Cos square A is cos square A by 1 plus sin square A. If I simplify the LHS, this is the result what I got. Okay na? Now, what I have to do? I need to simplify the RHS also. I am writing the result over here. Cos square A by 1 plus sin square A. Okay na? Further, can anything we can do it here? No. Okay. Now, that one, secant square A minus tan square A is 1, and secant, this one I will write it as 1 by cos square A, and tan square A I will write it as sin square A by cos square A. Now, 1 by, I will consider cos square A as LCM, and I will be remaining with 1 plus sin square A, and this cos square A will go to numerator and becomes cos square A by 1 plus sin square A. So whatever the result we got in the simplification of LHS, we got the same result in the simplification of RHS. So we can say that both are equal. This is, for some problems we need to solve like this. We need to simplify LHS and we will attain a result. After some time we will have some result, and that one we can't do anything. So this one, cos square A plus sin square A. The simplification for LHS is cos square A plus cos square A by 1 plus sin square A. And RHS, if we simplify, we also reach at the same junction that the LHS part whatever we got and RHS we got the same. So we can say that both are equal. Understand, children? This is one way of proving the problem. This is one way of proving the problem. Okay, na? Understand, children? First simplifying the LHS, and after that simplifying the RHS. If we got the same answer, we can say that LHS and RHS are equal. Next. Next one. Problem number 10. Problem number 10. Sin square theta tan theta plus cos square theta cot theta plus 2 sin theta cos theta is equal to, we need to prove tan theta plus cot theta. We need to prove tan theta plus cot theta. How to do this? How to do this? Any guesses? Any guesses from your side? What to do? Yes. Sin square theta tan theta, you can write it as sin theta by cos theta. So in total I can say sin cube theta by cos theta. Is that right, children? In total I can write sin square theta tan theta as sin square theta tan theta as, in total I can write sin cube theta by cos theta. Will you say yes for that? Okay, okay. Next. So how can we write cos square theta into cot theta? How can we write cos square theta into cot theta? It is cos cube theta by sin theta plus 2 sin theta cos theta. Okay, now what I'll do? I'll take LCM. Now here you can see, here what I get? Cos theta sin theta by cos theta. So sin theta into sin cube theta, sin power 4 theta. Next, cos cube theta, this one here I will get cos power 4 theta, and here I will get 2 sin square theta cos square theta. 2 sin square theta cos square theta. So what we can say here? Can I say this is sin square theta whole square? This one as cos square theta whole square, and this one as 2 into sin square theta into cos square theta by cos theta sin theta. Okay, children. Now what to do? Numerator is in the form of, oh, many students left. Okay, no problem. A plus B whole square. Kaushik, excellent. A plus B whole square, very good. A plus B whole square by cos theta sin theta. This step after this step, children, many of you will do, what you will do is Immediately you will put 1 over here in the numerator. Numerator లో 1 పెట్టేస్తారు. 1 పెట్టేస్తే ఆన్సర్ రావడానికి కొంత సమయం ఎక్కువ తీసుకుంటుంది. It will take more time to get the answer. 1 పెట్టకుండా what to do? Yes. Oh, this is not okay. Now we need to keep 1 only. Sorry, we need to keep 1 only. 1 square 1 by cos theta sin theta, which is nothing but secant theta cosecant theta. నేను కింద కూడా స్క్వేర్ ఉంది అనుకున్నాను, కింద స్క్వేర్ లేదు కదా, లేదా ఆన్సర్ అయిపోయి. ఓకే, నో ప్రాబ్లం. See here. So LHS part we got secant theta cosecant theta, LHS part. Now we need to simplify RHS part. So what is RHS? Tan theta. I will write it as sin theta by cos theta. Cot theta, I will write it as cos theta by sin theta. LCM cos theta sin theta. And here I get sin square theta, and here you will get cos square theta. So 1 by cos theta sin theta, and we know it is nothing but secant theta cosecant theta. So we got the same answer for LHS and RHS. We got the same answer for LHS and RHS. Okay, so both are equal. LHS and RHS both are equal. Understand, children? So no need to write down, just you can take the screenshots. You can take the screenshots. So can we move to the next problem? Can we move to the next one? Okay. Right. Problem number 11. Tan theta plus secant theta minus 1. Tan theta plus secant theta minus 1 into tan theta plus secant theta plus 1 is equal to 2 sin theta by 1 minus sin theta. 2 sin theta by 1 minus sin theta. So how to do this? Tan theta plus secant theta minus 1 into tan theta plus secant theta plus 1. So how to do this? Can I say A minus B into A plus B? A minus B into A plus B? A square minus B square. A square minus B square. So here what I can take, what I can see, sin theta. Sin theta by cos theta plus 1 by cos theta whole square minus 1. So the result is, if I take cos theta LCM, sin theta plus 1 whole square by cos theta whole square is equal to minus 1. Now this is the sin theta plus 1, I can write it as okay, sin theta plus 1 whole square, and this one cos theta whole square is nothing but cos square theta, na? So I'll write this one as cos square theta. Okay, which is nothing but 1 minus sine square theta minus 1. Now, sine theta plus 1 whole square by 1 minus sine square theta to 1 minus sine square theta. Taking LCM. By taking LCM. Now, children, can I take 1 plus sine theta common over here? 1 plus sine theta common over here. Can I take? Because 1 minus sine square theta, okay, I do that. 1 plus sine theta whole square minus, instead of this 1 minus sine square theta, I will write it as 1 plus sine theta into 1 minus sine theta by, and here again 1 minus sine square theta I will write 1 plus sine theta into 1 minus sine theta. Okay na? Now, numerator I will take 1 plus sine theta common. 1 plus sine theta common, and remaining is 1 plus sine theta minus 1 minus sine theta by 1 plus sine theta into 1 minus sine theta. Okay, so 1 plus sine theta get cancelled, 1 plus sine theta get cancelled. Now simplify, we can see the denominator answer. We got the denominator, just we need to simplify the numerator now. See, 1 plus sine theta minus 1 plus sine theta by 1 minus sine theta. So plus 1 minus 1 get cancelled. 2 sine theta by 1 minus sine theta. 2 sine theta by 1 minus sine theta. The result. 2 sine theta by 1 minus sine theta. Just once again, what we have to do, tan theta, sin theta by cos theta, secant theta, 1 by cos theta whole square. Now taking LCM cos theta, LCM. So sin theta plus 1 whole square by cos square theta minus 1. Cos square theta I can write it as 1 minus sin square theta, then 1 minus sin square theta LCM. So here sin theta plus 1 whole square minus 1 minus sin square theta. This 1 minus sin square theta and this one I am writing as a plus b, a minus b. In chapter, ఈ problem solving starting లోనే చెప్పాను. 1 minus sin square theta లేదా 1 minus cos square theta వీటన్నిటిని మనం a plus b, a minus b లో కన్వర్ట్ చేసుకోవాలి. We need to do that. So after converting like that, from the numerator, I took 1 plus sin theta common from the numerator here. So if I take 1 plus sin theta common, one more 1 plus sin theta is there and 1 minus sin theta. 1 plus sin theta get cancelled. 1 plus sin theta minus 1 plus sin theta. Plus 1 minus 1 get cancelled and we got the answer. Understand, children? Little bit lengthy problem, but nice problem. Okay na? Understand? Now problem number 11 done. And I think 1 hour is over. 1 hour is over. So the important points for today, you need to remember the identities, all the identities, and even how can we express tan A, how can we express cot A. And one more very important point, whenever we see like this, or like this, or like this, or like this, we need to assume that they are a square minus b square form. We need to assume that they are in the form of a square minus b square, so that we can write it as a plus b into A minus B form. This is very important for problem solving in trigonometric identities. Okay, children? Okay. Tomorrow 10 o'clock, we'll continue with this. Okay, na? So if you like this and you like, and tell to your friends also to see this video. Okay. Tomorrow, sharp 10 o'clock, we will meet again. Dhanyavad. I am signing off. Thank you. Thank you very much. Thank you. Bye. Thank you.